Alright guys, we are back. Welcome back to this video series about making old school games in Java with Libgdx. Today's video is going to be another one of those videos where I've wrote out all the code ahead of time because it is extensive and it is going to be pretty complex. I'll apologize ahead of time if I suck at explaining it. I'm not a math teacher, so there's going to be times when I'm not really sure what the best way to explain it to you is. Today we're going to get into some rotating the sprites, putting sprites in the world, sprite billboarding, that type of thing. And in my experience, this kind of stuff, you really have to like think about it for a while and maybe do some Googling for some other explanations too in order to sort of fully see what's going on. With that said, the code isn't crazy complicated. There's no crazy like coding technique going on here. So that's a good thing, right? Anyways, I'll get right into what I did since last time. So first off, I made a array list that's going to be holding all of the entities we're going to be putting in our world. Right now, this project isn't well organized. I just put it in this class, and this class is going to be very bloated as of today. In a better organized project, this list probably wouldn't be in this class, but for right now it is. We also made an entity scale vector, which for right now I just set to 0.2 and 0.32. Now, a scale of 0.2 on the x and a scale of 0.2 on the y, 32 on the y. This is going to determine how big the things that the player sees are. They could be, if you want something like Godzilla sized in the world, you're going to have to up these a lot, right? If you want something like Kart sized, you can play around with this until you feel that you've got the correct size for the things in your world. If you have multiple different kinds of objects like trees, Godzilla, and carts, you're going to have more than one of these vector scales for each one of those. And you'll see where this comes into play a little bit later. I know that sounds confusing now. By the end of the video, it will make sense. And here I've just added one entity to the world. We're going to explain the Sprite 3D class just in a second. I called it Sprite 3D. That's not really like a great name, but that's just what I want to call it because our sprite is like a sprite in the world, but it's also kind of 3D because it's rotating. I just thought it was kind of clever or something. But anyways, I just added one. Later, we'll add many more, probably not in this manner. Just kind of, adding new sprite, new pixmap, new file handle right into the list. But for now, that's going to be good enough to demonstrate it with this video. So what's up with... What should I do first? Actually, yeah, let's talk about the Sprite 3D class. So a sprite, an entity that exists in our world, is going to need some information. So first of all, it's going to have an image, a 2D image that represents it. Now we're not going to use a texture for that. We're going to use a pixmap, and I'll explain why in a minute. But yeah, it's going to have a pixel map of its own that represents what it looks like. In my case, today, I'm going to be using this little player, this sort of back of this cart guy. We're not going to do animation today in the way that we're not going to see all sides of him. We're only going to see his back today just to keep the video simple. So this is what I'm using, this 2D image that I'm putting into a pixel map right here. You can see player.png. I'm just adding it to my entities as a Sprite 3D, as a new pixel map, using a new file handle there. It also needs a sort value. Now, why does it need a sort value? Because in your world, you're going to have to find a way to sort entities on the screen. So if there's 5 carts on the screen, you need to know which ones how they should layer on top of each other. So if one cart is 10 world units away from the player in front of him, that cart needs to be and then there's another cart 5 units in front of the player. The 5 units cart needs to be drawn on top of the 10 units cart, right? Because if you were looking at the 5 units cart and then the 10 units away cart, the 5 units cart would be closer and would be somewhat blocking your view of the 10 units cart if he was right in front of him, right? So you need to be able to find a way to sort. In our case, we're going to sort just by sort of the Y position. So you see this. Well, actually, let's just this screen position here. So there's a world position and then there's a screen position. Sort of we're going to be sorting by screen position. I know that sounds weird, but it'll make sense once you see how things are drawn into the world. Cool. Uh, this is jumping thing. Actually, this is a remnant of an older project I was doing, and this actually isn't relevant for today's video at all. This is just a constructor setting everything up. So remember, screen position, world position, and this is its size. This is essentially the same thing as what we did here. Like I said, later we'll have to, like I said, this is probably a remnant of older code. Let me see here. Oh, no, it's not, because you'll see what we're going to do down here in a moment. See, this is why copy pasting code into a project, you forget things. And I worked on this a couple months ago, and I'm trying to explain it to y'all now, and it's just, I'm derping out on it a little bit. But I promise by the end of the video, we will get there and we will make sense. Cool. So screen position, world position, size. You'll see what size is for in a moment. Other than that, we're implementing the compare to. If you don't know what comparable is in Java, it's actually really simple, and it's probably worth Googling it, because the documentation for Java is like really good and probably offers you a better explanation of compare to than I would. But basically, this is going to help you sort and determine which one is closer to the player than the other. So all I've done in the render method is we're going to be drawing our entities after we've drawn the ground. Now, you might be wondering, why do the entities need the batch? And that's because the entities are actually not going to be drawn to the screen. They're going to be drawn to the pixel map, which this class represents. They're going to be drawn literally straight onto it. And then the pixel map is going to be drawn to the screen like normal. So the pixel map is still the only thing getting drawn to the screen, and these entities in the world are getting drawn to the pixel map. Remember, everything in the game is like a clever illusion. It's not actually 3D. It just kind of looks like it, as we'll see in a moment. Cool. So what does this draw entities method look like? It's actually pretty concise for everything that's going on, and we'll take a look at it. So this is a little bit of inefficient code I did. I duplicated this code down here. You generally don't want to duplicate this. But anyways, I did because it was easier for me to do it quickly to get this video out. Cool. So we have another array list here. What this is going to be is after the sort of position and like rotation and stuff of all of our entities is decided, they're going to be added to this list. Or, well, they're going to be added, their position and rotation and width and height and stuff are going to be decided, and then they're going to be added to this list. And then down here, we're actually just, because they implement the compare to interface, they can be sorted just by Java's collections sort of library, which is great, right? Because then we don't have to do the sorting manually. We're just gonna let Java handle it for us. This collections.sort thing is really awesome, actually, for a lot of things, not just for this game or any specific case. Anytime you don't have to implement a sorting algorithm yourself, I think is like a pretty good thing. Cool. So what are we doing here? Well, we're taking every entity in our entities array or array list, which right now is only one entity, but it can be as many as you want. It could be 1,000 if you want. Now keep in mind, if you had like 2 million entities in here, your game's gonna run like shit. Probably anyways, maybe not. But I don't think we're ever gonna have 1 million entities in there, so we could, though. It might be kind of fun just to see what happens to my computer if I did that. But anyways, so, and I left myself little notes here. You can read them as we go, but I'll also read them. So what we're doing here is we're determining, and wow, this is a descriptive variable name, huh? When I did this before, I was really determined to remember what this does. But all we're doing here is we're getting the entity's position, and we're sort of comparing that. His position in the world, by the way, which right now we've just set that to default to 0, 0. We're not changing it for the moment. We could, if we wanted to, we could change it on the fly by sort of making one of these and then, instantiating it and then changing. And that's how we'll move people in the world later, right? But anyways, we're getting his position, which right now is just 0, 0, and we're checking what the player's position is, and then we're just figuring out what the difference is on the X and Y, right? So now we know what the difference in position is on the X and Y. We know where the player is in the world relative to where the entity is in the world, the cart, the tree, whatever it may be, Godzilla, etc. And moving on. So what are we going to use this for? Well, we're going to use it in conjunction with the direction that the player is facing to figure out what the rotation on the entity needs to be, how the entity needs to rotate to be facing the player. Now, if this code looks a little confusing, it's actually pretty straightforward math concept. This is just the rotation matrix the basic rotation matrix written out as two separate numbers, X and Y, instead of like going into a vector. If you want to learn more about the rotation matrix, I really suggest just Googling it. There is so much information out there about it, basic linear algebra, all that stuff. I don't really think it would be a good idea for me to try and teach you much about it here. I would probably just suck at it compared to what you could find elsewhere on YouTube in like a better, more concise explanation or video. So, but just know what we're doing here is we're using our player's position relative to the entity and our player's direction that we're facing. Remember, we talked about this sort of direction vector last time, in the video about 3D projection. I don't think that was actually last video. I think it was the video before last. But anyways, cool. So, and we're using those two things together to see what our rotation needs to be on the entity to make it face the player. And then the next part is where we're scaling the sprite. So we're getting the sort of width and height of the actual sprite pixel map. And this is like somewhat arbitrary. I mean, if you have a bigger pixel map, it's going to be bigger, right? If you don't, it's going to be smaller by default. But then this is where scale is sort of important, and this is why I said this is a little bit arbitrary, because you're gonna scale it anyways to be whatever you want, bigger or smaller. So that's all this is doing. It's getting our projected. The reason why I called this projected cart width. Okay, I called this cart here. That's a remnant from the old code too, when I was calling it just carts, but it really should be entities because it's going to go for any entity in the world: trees, Godzilla, carts, whatever. King Kong, whatever's in the world. So, but the point is, the reason why I called it projected is because it's the projected width based on all this information, right? Based on the player's direction, his position relative to the entity, and also the rotation of the entity. So we need to get the size based on everything that came prior to this. Cool. So we're getting its size based in the world, based on all that stuff. We're getting its height in the world based on that stuff. Remember, we need to take the world scale into account, and the entity scale, and the rotation, and its original width and height in the pixel map, which, like I said, doesn't necessarily matter because you're going to change it with the entity scale anyways. Now, what is this? Well, this is basically checking if the entity would even be on the screen. So if his projected width or height is less than 1, that means the player can't even really see this entity, right? So we don't even want to add this to the entities that are going to be sorted because the player can't even see him. So this frame, we're not even going to draw this entity because the player can't see him this frame. Maybe next frame the player can see him. If that's the case, then we'll draw him. But otherwise, he doesn't exist as far as we're concerned. And this is a performance thing, right? Just because there's a million entities in the world, some of them might be behind the player. We don't need to draw them if he's not even going to see them, right? Once again, making games is all about clever illusions. Cool. I just noticed you can also see this old code because the way I did brackets here is different. That's totally fine though. So what are we doing here? So this is where we're sort of, well, exactly what it says, is get the sprite's location on the screen. So if the sprite were like flying around, it could potentially move up and down the screen, right? Uh, so we need to know its position not only in the world and what size it should be on the world, but its position on the screen is important too, right? So that's kind of what we're getting here, with everything taken into account, including like where we're drawing our horizon. If this part looks a little funky or if it doesn't make sense, I wouldn't worry about it too much. This is pretty much going to be like, you wouldn't be editing this too much anyways. You get the world scale here. Let me see. Is there anything here that's like really tricky? No, it's basically just figuring out your X and Y screen coordinate. And then you're, okay, so here's where we're using the size and stuff. Uh, so yeah, I messed up when I was talking about it earlier. I confused myself, but basically your projected width and height is going to go into the size. So we have position on the screen, like I said, position in the world, like I said, and this is size in the world. So the pixel map has a size, but this is size in the world, and I was mistaking that for the scale variable, but they are two separate things, even though technically the scale variable is really the only one that matters, because that's going to completely determine this projected width anyways. Cool. And sort of once we figured out, like I said, his screen position, his Y screen position, then we're going to we're going to use that to sort, right? Then we're going to add it to the sorting array. We're going to sort it. And then we're going to draw the, you can see I used cards here, the entities to, but I think entities is a better term because it's going to be anything in the game world. We can draw the entities to this pixel map. See, you can use this draw pixel map function that's in innate function in pixel map to draw other pixel maps to this pixel map. So it's kind of like pixel mapception, right? Inception. You're drawing a pixel map on your pixel map inside of your pixel map. Anyways, this part should be really simple. All we're doing is once we've sorted it, we're just basically looping through the entities again and then drawing them to the screen. This sort of like whole algorithm is probably like minorly inefficient considering we're like looping through the entities, then we're looping through the entities again. But it does work, and I'm going to show you that it does work. Cool. I think that's everything for us to look at it. So I've already started the game here, and you can see I put him at position 0, 0. If I rotate around, he disappears. Boom, he's back. And then if I go forward, he gets bigger, right? Like as I go forward, if I go up, I go down, you can see he's staying in place. And now it really looks like I'm flying in the world, right? Because he's staying there. So yeah, check him out. And if we, let me see if I can actually, if we strafe around him, we can see that he rotates. Pretty cool, huh? Now later, hopefully I'll make a video where when we strafe like this, his sprite will be changing to make him look truly 3D. Right now, all we do is we see his back. But yeah, it's off screen, on screen again. So you can move closer. This is funny. So this is actually a problem we're going to have to solve later, where he disappears if he goes into the mountains. Ideally, what we want to do is his head would be drawn on top of the mountains, and we can do that, and we will. It's not something I'm going to fix in this video. Anyways, so for anyone out there that is watching the video and you want to use this code, sort of feel free to. If you feel like the video goes by too fast for you to copy the code, ask me for it. I'll send you the code. I'll post it up in a Google Drive or something that you can access. So you can just copy paste it. or you can like pause the video at a moment like right now and look at it and just copy it down if you feel that's better. Whatever works for you, just ask me. If something just like totally blew your mind and makes no sense in the video, you can ask me that too. Maybe I can help explain. Also try Googling it. And sometimes I find it helps to just get in here and experiment, right? Maybe you're like a little bit curious about the scale vector and you want to change the numbers. Go ahead, change the numbers, see what happens on the screen. Maybe you're curious about the sort of the scale here or the rotation. Go ahead and put some arbitrary numbers in for a rotation. See if it does just some completely wacky stuff. Whatever you want to do, you know, I'm just trying to provide the code for you so that you can sort of go forth and try to make old school games in Java or whatever language you're using. And you can see our background is still working quite nicely or whatever. So if you found this useful, great. I think that the sort of coming along, remember in this series, I'm not going to be making a complete game, but we're going to go through just a mess of mechanics. I don't know what I'm going to do next. I'm going to have to try and find something fun to do. We've already gotten past a lot of the fun parts. Anyways, I'm just rambling now. I will see you guys next time. I hope you got something out of this. Cool. Thanks for watching.